Welcome back to school. Hope you all had a great Christmas break and now you're excited to be back and to start learning some trigonometry. You by now should have gotten a new assignment sheet and journal, and hopefully you brought with you your green trig book. If you did not switch books with me before Christmas, you'll need to put your orange book back in the cabinet and get out a green trig book with the same number. Well, since we're ready to start our study of trigonometry, we ought to first talk about what does trigonometry mean. Now, you're going to discover that most of you who were with me last year during the end of Algebra 2, you're going to recognize a lot of today's stuff, and one of those should be, what does trigonometry mean? And since you have the sheet sitting in front of you, you already know that it is actually made up of two parts. The word trigonon, which means triangle, and of course we know anything that ends with metry, as in geometry, means measure. So in this case, trigonometry is primarily the study of triangle measure. How`ever, that is not all we use in trigonometry. We will also be talking about the study of circles, how much the area of a sector of a circle is, how fast if something is spinning, how fast is the center moving, how fast is the point on the edge moving. Later on, we will be studying projectile motion. There are many, many, many other uses. Those of you who are into your physics will talk about forces and understand how they can be represented with trigonometry. So there are many, many areas and lots of real-world applications in trigonometry. However, today is what I call trig basics. What are the basic facts you need to know to pretty much work any trigonometry problems? And the first part, of course, is if we're working with angles and we're working with a coordinate system, you have to know where to place your angles. And as you can see from this diagram, we naturally always put the vertex of an angle at the origin, and we always put this initial side of the angle where the side where the angle starts, is always sitting on the positive x-axis. Then an angle moves around from there where the angle stops is called its terminal side, because that's where it terminates. The angle itself can be represented with a letter or a Greek letter. When we work on coordinate systems, we use Greek letters. When we're working with triangles in the plane, we'll use alphabetic letters like ABC. So here, since we are talking about an angle on a coordinate system, I'm going to use a Greek letter. And does anybody remember the most common Greek letter we use to represent angles? And yes, you should be going, oh yeah, that circle with a line through it thing that we know as theta. You don't have to use theta. You can actually use any other Greek letter, and this book will mix them up on you. You will see quite a few of them today alone. You'll be seeing alpha, the fish. You'll be seeing beta, which is basically a bee with a tail on it. You might see lowercase omega and a number of others. Don't let that throw you. It's just like saying angle A, angle B, angle C. We just use Greek letters to represent angles on a coordinate system. Now, one of the things we have to talk about is the fact that the location of an angle on a coordinate system can actually represent several different angles, and they are called coterminal angles. Because, for example, if I was to draw here a coordinate system and ask you to show me where an angle of 430 degrees is on that coordinate system, there are actually other angles that end in that same location. They have the same terminal side. That's why they're called coterminal, because they share the same terminal side. Okay. We know that if I start with an angle of 430 degrees, that's certainly more than 360. So therefore, that means that this angle went completely around the circle, 360 degrees, and then went how much more? Yes, it would have went another 70, which would keep it in the first quadrant. So it would be an angle that ends in about this location. Therefore, since it's the same location as where a 70-degree angle would lie, we would say 70 degrees is coterminal with 430 degrees. Okay, you're going to be asked to name a positive angle and a negative angle, which are coterminal. Negative angles simply go around backwards. So if you're asked to name a coterminal angle, a negative coterminal angle, that means you need to start at the positive x-axis, and you need to ask yourself, if I had my angle go around the circle backwards, how many degrees would that be? Well, obviously if we use 70 over here, the rest of it has to be whatever 360 minus 70 is. So yes, we would get a negative 290 degrees as also a coterminal angle. Now, they're always going to ask you to name the smallest positive and negative coterminal angles you can come up with that aren't the same as the given angle. So in this case, 70 and negative 290 would be considered coterminal. Okay. We're going to do another example here, because sometimes this causes a little bit of trouble. If I ask you to find me two angles that are coterminal with negative 220, that means I want another positive angle and another negative angle that end in the same location. So we know that an angle of 220 degrees is going to start on the positive x-axis, but it's going to go backwards from there since it's negative. So if I go backwards, I'm going to go, there would be backwards negative 90, negative 180, 220 is another 40 more, so I'm going to be a little ways up into this quadrant. And so that, going backwards, would be negative 220 degrees. Okay, I need you to find a positive angle that ends in the same location. So we would be looking for an angle that starts over here at 0 degrees again, and moves in the normal positive direction and comes around to this point. That would be the smallest angle we can find. But once again, if we've used up 220 degrees going along the white line, how many degrees would be left going the other way on the circle? And hopefully you're shouting 140 degrees would make 360. So yes, 140 degrees would be a positive angle that ends in the same location. Okay, now here's the tricky part. We also need to name another negative angle that ends in the same spot. Now since we've done 220, that is actually the smallest one there would be. So to get another negative angle that ends in the same location, we would actually have to go completely around the circle backwards and then go another loop, or part of a loop, to that point. In which case, I have gone 360 plus another 220, which would be a total of 580 degrees I passed through. Because I went in the backwards direction, I will write my answer as negative 580. You need to recognize that negative angles simply mean you went backwards. It doesn't work to add 360s and subtract 360s, which is what people try to do. You have to think in terms of visualizing the picture, how many degrees did I pass through. The positive indicates you went around in the positive direction, the negative indicates you went around in the negative direction. It's all we're talking about. So in this case, our two coterminal angles would be 140 and negative 580 degrees. And you would leave it at that. All right, now sometimes we need to break angles down into smaller increments. Now you all look at a protractor and probably think, well, hey, a 1 degree angle is really, really tiny on a protractor. But if you extend that 1 degree angle outward for miles, you'll discover once you've gone out a number of miles that that suddenly is a very wide angle when you've moved out that far. So surveyors in particular need to break angles down into smaller increments. So they did it basically based on a clock. A 1 degree angle equals 60 minutes. The minute symbol is simply a single prime symbol, as shown here. That's 60 minutes. So a 1 degree angle can be broken down into 60 separate parts. Okay, if we need to go even smaller, a 1 minute angle is equal to 60 seconds. So if you see the double prime mark, that indicates seconds. Okay. What I need you to do is to be able to do some arithmetic working with degrees, minutes, and seconds. So what I have here is an addition problem. You have an angle of 32 degrees, 40 minutes, 51 seconds, which is added to an angle of 13 degrees, 24 minutes, and 11 seconds. So when you add them together, first you're going to just add down, and you're going to discover that, okay, I would add up to 62 seconds, 64 minutes, and 45 degrees. Can I have an answer like that? And hopefully you're screaming, no, you can't have minutes and seconds that are over 60. So it's kind of like the old borrowing and carrying thing back when you learned basic addition. Since this 62 minutes is over 60, I actually would take 60 minutes out and change that, leave it as just 2 minutes. That would cause me to add, 2 seconds, and that would cause me to add 1 minute over here. So now I actually have 65 minutes. Well, I don't want to be over 60. So I'm going to take the 60 off. I'm going to leave 5 minutes behind. I'm going to come over here and now add another degree on. So I actually end up with 46 degrees, 5 minutes, and 2 seconds. A typical problem you're also going to see, we work with angles in degrees and minutes quite a bit in trigonometry. I gave you here, this is a right angle. This top angle is 53 degrees, 12 minutes. How big is the bottom angle? Well, if it was just 53 degrees, you all would jump right in there and go, okay, well, all I have to do is take 90 degrees and subtract 53 degrees to get the complementary angle. But this is 53 degrees, 12 minutes. So you have to realize that that is really 0 minutes to start with. I can't subtract 12 from 0, so that means I got to borrow here, old-fashioned terms. So if I do some borrowing, I'm going to take away 1 degree, which is going to leave me 89 degrees here. 89 degrees will give me 60 minutes then when I borrow. Key thing is to remember you're not borrowing in tens, you're borrowing in 60s. Now I can subtract. 60 minutes minus 12 minutes is going to leave me with 48 minutes. 89 minus 53 is going to leave me with 36 degrees. And so my answer would be 36 degrees, 48 minutes. Now that also leads us to the question of, can your calculator do degrees, minutes, and seconds? And sure it can. You'll discover you have an angle menu. Your angle menu has the degree and minute symbols in it. It is under Second App. Okay, unfortunately, they didn't put the seconds in there. The seconds are at alpha plus sign. If you go ahead and type that in your calculator, just as is, 15 degrees, 42 minutes, 36 seconds, and hit enter, your calculator will convert it to a decimal for you, and that decimal should turn out to be 15.71 degrees. Okay, since I'm about to run out of time, I'm going to stop the recording here, and we'll pick it up with part 2 in just a second.